Hey everyone, welcome to today's Explainer. We're going to be tracking artificial intelligence's absolute rocket ship journey from a novelty cloud service into deeply embedded, highly regulated global infrastructure. We've got some incredibly critical data to unpack today to see how this technology is fundamentally growing up. Here's our roadmap for today. First, the intelligence price floor, then the public market wave, moving on to the physical AI era, and wrapping up with regulating the AI battlefield. All right, part one, the intelligence price floor. 14 cents. I mean, think about that for a second. For literally less than the cost of a gumball, Deepseek's V4 Flash production model can now process 1 million input tokens. That's a total fraction of what this level of compute cost just a few months ago. Deepseek just officially pushed its Frontier V4 model into stable production. And this ultra-fast V4 Flash variant, it's not just 14 cents for input, it's only 28 cents per million output tokens. And the absolute kicker here is that it matches top-tier models on benchmark software engineering tests. So what does this all mean? Well, it sets a brutal new intelligence price floor, and it's putting insane downward pressure across the entire commercial API industry. So if you're an enterprise developer, you can now affordably deploy sophisticated coding and automation agents at massive scale. When high-performing frontier models cost pennies, automating workflows becomes achievable at a fraction of standard API costs. You're not just buying software anymore, right? You are basically renting highly capable digital labor for practically nothing. Moving right along to Section 2, the public market wave. Now we're seeing Chinese frontier AI labs advancing their public IPO filings, and the scale is just massive. Take a look at this staggering $71 billion valuation target for Deepseek. Directly contrast it with the $50 billion target for Moonshot AI as they both make aggressive moves toward the Hong Kong and Shanghai exchanges. The real so what here is this massive shift in accountability. We are officially leaving that era of wild private venture hype where growth was literally the only thing that mattered, and we're entering the public market arena. Public markets demand absolute proof of sustained revenue models and positive unit economics. Basically, these labs now have to prove that their insanely cheap intelligence can actually turn a real profit. Okay, let's get into some specific instructions on how to actually apply this new tech, looking at what heavy hitters like Intel and Google Cloud are doing. Step 1, you expand your foundational cloud agreements. Step 2, you leverage those plunging 14-cent token costs we just measured to affordably embed agentic AI directly into your global engineering pipelines. And step 3, you deploy these agents to streamline things like complex silicon design and massive physical supply chain logistics. To put that into perspective, you are literally instructing pennies worth of AI to manage multi-million-dollar physical manufacturing operations. It's wild. Which perfectly tees up Section 3, the physical AI era. So what exactly is physical AI? Put simply, it means untethering robots from the cloud. Instead of a robot waiting for a server halfway across the globe to tell it how to move, these autonomous systems are processing spatial perception and reasoning locally, right there on the device. No high-latency cloud processing required at all. Usually, cloud-dependent AI needs ultra-stable networks, and it still suffers from high latency. But on-device optimization specialists like Noda AI are completely changing the game over in the AMD Robotics Partner Network. They're bringing highly compressed physical AI models directly to resource-constrained robotics platforms. The result? Ultra-low latency that lets these robots function in completely autonomous, totally untethered environments. Of course, to pull this off, physical AI needs a rock-solid hardware foundation. To handle the huge energy demands of hosting these local inference clusters, system integrators like MSI are rolling out expanded enterprise server lineups. These are powered by the 6th-gen AMD EPYC architecture, which is specifically designed for high-density AI acceleration. We're talking exponentially higher compute density per watt in the data center. Now think about this. When AI is physically piloting industrial robotics or medical IoT devices, a security breach isn't just some data leak. It's a literal physical danger. Standard security just doesn't cut it anymore. That's why we're seeing companies like Apex AI and Terra Quantum demonstrating end-to-end post-quantum cryptographic protection. Securing this autonomous hardware against future quantum threats? Yeah, that's no longer optional. It's an absolutely mandatory safety parameter. And that brings us to our final section, Part 4, Regulating the AI Battlefield. Governments are finally stepping in, and they're bringing real teeth to the table. Under the U.S. Executive Order's Advanced AI Framework, we're seeing active, practical enforcement. AI labs are now facing strict regulatory checkpoints. They've got mandatory pre-release oversight, deep security audits, and strict safety evaluations for all high-tier models before they ever see the light of day. But domestic regulation is, well, it's only half the battle, right? That leads us to a massive geopolitical hurdle. When AI is running on physical robots, how exactly do we globally standardize autonomous dual-use technology, like civilian AI chips, when they inevitably get deployed in military contexts? This domestic push has actually sparked some major diplomatic urgency on a global scale. We're seeing UN leadership actively calling for binding international standards. They are impartially pushing to regulate exactly how these advanced silicon chips and autonomous robots are utilized on the battlefield. So, hardware export controls? They're now front and center as a critical matter of global security. So, when we zoom out and look at the whole picture from 14-cent tokens all the way to UN Security Council debates, I want to leave you with this question to chew on. As AI transitions from a simple digital tool into global physical infrastructure, is its true power found in its raw intelligence or in its real-world integration? Let me know what you think. And hey, remember to subscribe to AI Vanguard AI to stay at the cutting edge of industrial AI. If you found this synthesis valuable, please like, comment, and share. Thanks so much for joining me on this explainer, and I'll catch you next time.